Hello guys, in this video we introduce the concept of an exponential function. Let's look at an example. Suppose you have y equals 2 to the power of x. If we wanted to draw this function, a good approach would be to use a table of values. To be honest, anytime you come across a graph that's unfamiliar where you have to draw it, a table of values is often a good place to start. So let's look here. We have x, we have y, and let's pick some values. I'm going to pick going from -3 up to 3. So -3, -2, -1, 0, 1, 2, 3. Okay, let's start with x equals 3. So if x equals 3, then y is equal to 2 to the power 3. So that's going to be 8. If x equals 2, then y is equal to 2 to the power of 2. So that's going to be 4. If x is equal to 1, then y is going to be 2 to the power of 1, which is 2. If x is equal to 0, then y is equal to 2 to the power of 0, which is equal to 1. If it's -1, you get y equals 2 to the power of -1, which is a half. If x is -2, then you get that y is equal to 2 to the power of -2, which is equal to 1/4. If x is equal to -3, then y is equal to 2 to the power of -3, which is 1/8. Okay, so that's what the table of values would look like. Let's see if we can actually transfer that to what a graph would look like. Okay, so here I have a rough sketch of some coordinate axes, and I'm just going to plot the points. So if x is equal to 3, then y is equal to 8. So that's about there. If x is equal to 2, then y is equal to 4. So that's about here, a bit higher. If x is equal to 1, then y is equal to 2. So we go about here. If it's 0, for x that is, then y is equal to 1. So that's about here. Ooh, excuse me. So if it is equal to 0, then that's 1, which is about here. And if it's equal to -1, it's a half, which is about here. And for -2, it's a quarter, which gets just a little bit smaller. Let me do it so that it gets a bit smaller. And so on. So there are some things that you will notice. By the laws of indices, you will never actually get 0 for y, and of course you will never get a negative number. So it's just going to keep getting smaller and getting closer and closer to the x-axis, but we'll never touch it. So let's just draw the general curve then. So based on the points that we've seen, we're going to connect those or make an attempt. So just really roughly, that's going to look something like this, where we keep getting closer to the x-axis and we never get there. And if it's a general, if this is y is equal to 2 to the power of x, the important things to note are that this point is where y is equal to 1, because this is where you have 2 to the power of 0. And the other thing that's important is to note the asymptote, which is the x-axis or the line y equals 0. Okay, so let's just generalize this. If you have a graph for y is equal to a to the x, where a is some constant, and a is greater than 1, then your curve will look something like this, where the y-intercept is 1, and the asymptote, let's just get the asymptote, is the x-axis, or the line y equals 0. Okay, we'll have a look at the situation where a is not greater than 1. So we'll look at what happens if it's between 0 and 1 strictly, and what happens if it's equal to 1, and also what happens when it's negative. But that's it for this video.